Today I want to talk about saving money. Now the idea behind saving money is that you're putting it away and you're hoping that eventually when you take that money out, well, if you're saving it somewhere, it grows. So to save money, you put it into an account. Then you leave it there, and then someday later, you take it out, and it's grown. So there's some extra. And this extra is what we call interest. Interest is a percentage of the amount of money that you put away, that you get back at the end, and it's based on the time that you leave it in there, and it's based on the amount of money that you actually put in. So interest is a percent of money earned. And it depends on the amount that you put in the beginning, that's why it's a percent, and the time you've left it in there. Now when we're talking about savings, what we typically like to think about then is the different ways you could save. One way to save is to essentially give a loan to a friend or a family member. When we usually give a loan to a friend or a family member, if we ever collect interest on it, we typically do what's called simple interest. So we'll start there. Because interest is typically dependent on the amount of money that you invest and the amount of time that you leave the investment in there, what we're going to do then is we're going to talk about how to get the interest. So let's let I equal the interest, the actual amount of money that you get at the very end, and let's let P equal the principal investment, suppose you want to charge some interest rate. So depending on the number of years, each year you're going to collect some percentage. We'll call that little r. It's the nominal annual interest rate. And let's let t equal the number of years. Now when we talk about simple interest, what you're typically going to do is you're going to say, hey, I'm loaning you the money, so maybe $100, and when you pay it back, I want you to give me 3% for each year you kept the money. In other words, $3 each year that you have the money. So maybe next year, if you pay it back, you owe me the $100 that I originally gave you, plus $3 more. If 2 years goes by, I want $3 or 3% for each year. So after 2 years, you give me back my $100, and you give me back $3 for the first year and $3 for the second year, so a total of $6. Well, how do we calculate the interest? Is basically this. We're going to take the interest and set it equal to however much money I give you, multiplied by the rate, so R, multiplied by time, T, or the number of years. R is going to be an interest rate, and it's going to be in decimal form, so this actually works out. So here's an example. The interest on $100 after 3 years at 5%. So 5% would be the nominal annual interest rate, $100 would be the principal investment, and 3 years would be the time in years. So how much interest do you end up getting at the very end of that? Well, the interest is going to be equal to 100 times R, 0.05, times 3, and what you end up getting is 100 times 0.05 is 5. 5 times 3 is 15. So the interest that accumulates over the process of this loan, or this savings, is $15. If you ever want to know how much the total is accumulated, we call that A. A stands for the amount accumulated. So A would be equal to, well, how much money do you get back altogether? You better get your principal back, and you should get the interest. So it's equal to P plus I. Now another way to write that is P plus I, but the I in interest is PRT. And the formula that we really like to go with is A equals P times 1 plus RT. Now the interest formula is great, but a lot of times we just like to know, so when your friend gets done borrowing the money from you, and you're saving it, essentially through your friend or your family member, your friend typically likes to know, how much do I have to pay you back? And how much I have to pay you back is the A, because they owe you the principal and the interest. So this is the one we're going to kind of stick with for a little while. So in this example, $100 at 5% for 3 years, we would say that A is equal to 100 times 1 plus R, so 0.05, times T, which is 3, which is equal to 100 times 1 plus 0.15 when you multiply 3 times 0.05, which is equal to 100 times 1.15, which is equal to 115. So altogether, your savings, your amount accumulated, would be $115. That's simple interest. It's called simple because it's actually not too bad to compute, but it's also simple because you're not really thinking about gaining interest on your interest. When we think about gaining interest on our interest, we get to what's called compound interest. And here's the way that I like to think about compound interest. If it's a friend, are you really going to have your feelings hurt if they don't pay you interest on your interest? No, it's not too big of a deal. But what about the bank? Say you put your money into the bank. And so, for example, what would end up happening if I put my money into the bank is this. If my nominal annual interest rate is 0.05, or 5%, let's put it to 0.05, then what would end up happening if I start thinking about year to year? So let's do the simple interest. And then I'm going to rig it. If I go from year to year, at year 0, just think back on the one example we were just doing a second ago. At year 0, I would have $100. At year 1, I would have $105. I get 5%. At year 2, I'd have 110. At year 3, I'd have 115. To get these, just plug 1, 2, and 3 into the amount accumulated formula. What if I kind of rig it? What if instead, think about like putting this money into a bank. So you put $100 in the beginning, and then at year 1, you have $105 because you get 5% interest. Now, if you leave it in the bank, and the bank is doing simple interest, then what will end up happening is, at year 2, you'd have $110. But what if, instead, after 1 year of leaving your money in the bank, you go back to the bank and you say, I would like my $105 back. And they hand you the $105. Alright, so let's just imagine that this eraser is the $105. So the bank hands you the $105. Now you have it back in your hands. And you almost pretend like you've just showed up to the bank for the first time and you go, hi, I have $105 I would like to invest. Here. And so now the bank has $105 back. So really what just happened was, it just switched hands. The bank gave you your $105 that you earned, and you gave it back to the bank. Now the bank is holding on to your $105. But when you get to year 2, when you ask how much money you now have, technically you've left $105 in there for a year, and you earn 5% interest on the entire $105. So you get 5% on the entire $105 because you've taken it out and reinvested it. So now, if I plug this into that formula, the A equals P times 1 plus RT, I end up getting $110.25. And we do the same thing. We pull the $110.25 out, and we put it back in. And on year 3, when I do that, I get $115.76. Now, it might not seem like that big of a deal. Ooh, I've got an extra 76 cents after 3 years. But anything extra starts to build. Because if you keep on doing this for 10, 20, 30 years, that number starts to build up. Why? Because you're earning interest on your interest. So that brings us to a new type of system, compound interest. You can think about compounding as as if you are going in each year and you're pulling your money out and putting it back in. Compounding, each time you compound, it's kind of like your money is being reinvested. Really what it is it's those times when you're earning interest on your interest. So compound interest. So for compound interest we have something extra. We have M. M is going to be equal to the number of times you compound per year. So the number of times you're not really doing it, but you're going into the bank, pulling the money out and putting it back in. This new value we call M, and it allows us to talk about earning interest on our interest. So compound interest, you earn interest on the interest. Okay, so how does this work? Everything else is the same, but now I'm going to give you a new formula. The new formula looks something like this. A equals P times 1 plus R over M. R is still your nominal annual interest rate, raised to the MT. Alright, so like I told you a second ago, if you had $100 and you invested at 5%, let's see what would happen after maybe 30 years. So $100 invested at 5% nominal annual interest rate for 30 years. And let's say it's compounded monthly. So the amount accumulated is going to be equal to $100 times 1 plus the rate 0.05 over 12. The reason it's over 12 is because if you compound every month, then the number of times you compound per year will be 12, raised to the 12 times 30. Now when I do this, I need to follow the order of operations. So the very first thing I'm going to do is I'm going to work inside the parentheses. So I'm going to take 0.05 divided by 12. And I get 0.0041666666. Once I take the number 0.05 divided by 12 and I get the 0.00416666, then I add it to 1. Now when I add it to 1 it turns into this, 1.00416666. So now that I've got the parenthesis kind of finished up, the next thing I'm going to do is I'm going to take the exponent. Now the exponent actually has two things being multiplied together, 12 and 30. That makes 360. So right now, what I've done was I divided these two numbers, and then I added it to the 1 to get this number. And now I'm going to take this to the exponent 360. So I'm going to raise it to the 360th power. And I end up getting, this is equal to 100 times 4.46774313. Which is equal to $446.77 if I round it to the nearest cent. So an $100 investment compounded monthly at 5% gives you $446.77 at the end of 30 years. You just plug it into the formula and actually run the calculation. Just to know what would happen if I did the simple interest, I would simply get 0.05 multiplied by the 30 years, added to 1. I get $250, right? So I ended up getting $5 for each year for 30 years. So I get $150 plus my principal back, I get $250. So now we're talking about almost an extra $200 by using the compound interest. So it starts to really make a difference when you're able to earn your interest on your interest. One of the things you're going to ask is what happens with compound interest if I compound more often? So can I compound weekly? Sure. You want to do weekly? You just change the number to 52. Change this number to 52, and it's going to give you a different value. In fact, let's just check real quick. If I did weekly, I'd have 0.05 divided by 52 plus 1, and then I'd raise it to the 52 times, or 12 times, 52 times 30, and then I multiply that by 100. I get $447.85, so about an extra $1, right? If I do this daily, I get a little bit more money. And if you keep on playing this game, you can compound all sorts of different amounts of time. If you want to, you could compound an infinite number of times, in other words, continuously, and that gives us actually a different formula. So what if we compound continuously? Then the formula is A equals P e to the RT. Now E it's just a number, and it's the Euler's number. It's the natural number, and it's approximately 2.72. Your calculator has an E button on there. Usually when you click it, it usually says E to the, because you typically only use it if you're going to raise it to a power. In our scenario, $100 at 5%, compounded continuously, for 30 years, you could try to figure out what would end up happening. And so you would end up getting A is equal to 100, e to the 0.05 times 30. So I would multiply the 0.05 times 30 first, and then I would take e to that power, and then I multiply it by 100, and I'm getting 448.17. In other words, the maximum amount of money that you can get from 5% nominal annual interest rate would be this. You're compounding continuously. It's not even every second or every millisecond. It's just all the time. It's compounding nonstop. So you end up getting $448.17. One of the interesting things about compound interest is that if we look at what happens, you don't really get 5% back at the end of the year. So it's not really 5% each year. Well, we need to double check it. So let's look at the $100 at 5%. Let's go back to monthly, compounded monthly. Just for 1 year. Now, if I get 5% at the end of the year, I get $5. In other words, my amount accumulated should be 105. But that's not what I'm going to get. Let's just check it. A is equal to 100 times 1 plus 0.05 over 12 raised to the 12 times 1, which is equal to, so again I'm going to take the 0.05, divide by the 12, add that to the 1, raise that to the 12th power, and then multiply by 100, and I get $105.12. So really I'm getting 5.12%. That is not the same thing as my 5%. Right? So why am I getting that? It's because I'm compounding. I'm getting a little bit more. We call this the APY. So the APY is just another name for what percent you actually get at the end of the year. And the APY stands for annual percentage yield. So this is called the APY. And again, it stands for annual percentage yield. So how do we get the APY? If you ever want to know what the APY is, what you do is you take APY is equal to 1 plus R over M raised to the M and subtract 1. And if we were to plug our numbers in here, so for us, if we plug in our 5% compounded monthly, APY would be equal to 1 plus 0.05 over M, 12, raised to the 12th power, minus 1. And we'd end up getting 1.0512 minus 1, which is equal to 0.0512, or 5.12%. So the APY is the actual percentage that you're getting at the end of the year, which is slightly different. one more formula I want to show, and that formula is, in general, this all has been hinged on the idea that you take a certain amount of money, you put it in the bank, you leave it there for a number of years, and you come back and you find out how much money is in there. That's not really how people save money. The way that people really save money is they take their money and they put it in the bank once a month, maybe $25 a month or $50 a month. They just keep on periodically putting in the money. So we're going to add a new thing called our periodic deposit, which we're going to call D for deposit. Periodic deposit. And this runs on the idea that you put a certain amount of money away each month, and you want to figure out how much money you've accumulated over time. So amount accumulated is A. It's dependent on your periodic deposit. Say you're putting in $50 a month or something like that, so it'd be D, times, and then it is 1 plus R over M raised to the MT minus 1 all over R over M. So this is the last formula I'm going to talk about, and I want to talk about an example using this. So suppose you're putting away $50 a month for 10 years. So put away, invest, $50, well it's not really an investment, I guess you're going to save $50 per month for 10 years at an annual nominal interest rate of, let's say, 4%. So let's find out how much you accumulate after time. Well, the amount would be equal to 50 multiplied by 1 plus R, 0.04, over, okay, I need to tell you how often it's compounded. Let's say it's compounded daily. Actually, this is one thing that we have to make sure we don't make a mistake on. Since you're putting it in per month, we need to find a savings account for this particular formula that compounds monthly. So this will always match. Now, it doesn't always match in the real world. Your savings account might actually compound weekly. But for us, our formula works based on the idea that they compound monthly. The numbers that you get will only be slightly different. They would be a little bit different, but for us, this is okay. The formula that we have to use if it compounds daily, but we're putting money away each month, it's going to be a little bit more complicated. But we'll do compound monthly. So 0.04 divided by 12, raised to the 12, multiplied by 10 years, 10, minus 1, over 0.04 divided by 12. Alright, so for this one, it's a longer formula to work through, but let me kind of tell you how I'm going to do the calculation. So I'm going to work out the numerator and the denominator separately, and then I'm going to divide and multiply by 50. So what do I have to do first? I'm going to divide that 0.04 divided by 12. And I get 0.003 is repeating. So you go 50 times the fraction. On the denominator side, I get 0.003. On the numerator side, now technically in my calculator, I still have the 0.003 is repeating, and that's also this number. So I'm going to add it to 1, and then I'm going to raise it to the 120th power, and then I'm going to subtract 1, and I get 0.490832682. Now I'm going to divide that by 0.003 is repeating, and I get 147.2498, and I multiply that number by 50, and I get $7,362.49. So at the end of 10 years, if you put $50 away a month, and you get 4% interest compounded monthly, you will have $7,362.49. This formula tells you how to do that. Now there is another formula that's associated to this. Suppose that you have something you're saving up for, like you're saving up to go on a trip or something like that. You can use a variant of this formula. The calculations go the same. Now the variant for this formula looks something like this. If you're solving for this, that means that you know the amount that you want to save up. Say you want to save up $5,000, so you put 5,000 in for A, so you get A times R over M over 1 plus R over M raised to the MT minus 1. That's it. That's the formula you end up using. So now, suppose you know that you want $1,000 or let's say $5,000. So you can go on a really nice trip. You put 5,000 in for A. You put your interest rate in here. Your how many times it compounds per year. How much time you have to save up the money. Maybe you're saving up for 2 years from now. So put in t equals 2. Plug it all in, and whatever number you get right here, that's how much money you need to put away per month. Right. So you should be doing compounded monthly if you're going to be saving it up each month. If you want to save money each week, change it to compound weekly and see how much you have time to do that. And again, the bank is not going to compound based on when you're saving your money. On the other hand, it should still work out pretty nice to get you a pretty good estimate as to how much you have to save each month.